Hello and welcome to another episode of the EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in building and urban efficiency. I'm your host, John Sheff, Danfoss's Director of Public and Industry Affairs. You can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever it is you get your podcasts. Today we have Sankar with us, our Danfoss's global application expert focusing on package systems and data centers. Sankar and I are going to discuss the latest trends in indoor air quality, which is a really hot topic right now. Sankar, thanks for joining us. Please tell us a bit about yourself and your role at Danfoss.
Thank you, John, for having me. So my name is Sankar Padhmanabhan, and I'm the global application expert in Danfoss, and I focus mostly in package systems such as rooftops, DOAS systems, and also data centers.
Great. Yeah, and these are becoming even more important right now, thanks to everything going on between the refrigerant transition, but especially because of all the complications of the global pandemic and COVID-19. So briefly explain why indoor air quality, or IAQ, is such a topic of conversation right now.
Okay, yeah. What a relevant question. So indoor air quality is more relevant now than ever, John. We have all seen over the last 2 years, we have come to appreciate how important indoor air quality is, mainly because of the health reasons. Until before COVID pandemic, we all thought the indoor air quality, at least our industry thought indoor air quality was only about temperature and humidity. But the recent guidelines and COVID has, of course, shed light on it, that indoor air quality means more than just comfort, and also means health risks, and how can we mitigate health risks. So yeah, it's very important now, and we are actually increasing the scope of the indoor air quality definition, and I think it's going to improve, and we are going to have more focus on this as we go along. ASHRAE and World Health Organization has put that focus and said indoor air quality should mean bringing more fresh outdoor air into the occupied zone.
Yeah, I mean, I think it's incredibly important. Before the pandemic, indoor air quality meant, there are these studies linking it to office productivity and trying to quantify it there. But now it really is a health issue, and it really is the key issue for businesses, for property owners trying to get people back to the office. I mean, this is really the key issue. Now, in that context, explain what DOAS systems are and what they mean for indoor air quality.
DOAS is actually it's just an acronym for Dedicated Outdoor Air Systems. So, as the name suggests, the purpose of this system is to bring in fresh outdoor air and supply to the occupied spaces, either directly to the spaces or through a primary air conditioning system. So in US, ASHRAE 62, which is a standard that specifies how much fresh outdoor air needs to be brought into occupied spaces, right? So depending on what the spaces do, there are different amounts of outside air you need to bring in. So there are HVAC systems which can do it, but not efficiently, because many operational and design constraints are there in bringing a lot of fresh air at various ambient conditions. So that's where the DOAS systems will come into picture. Okay, a DOAS system solves the issue of bringing large amount of conditioned air. It could be up to 100% of the airflow needs to be fresh outdoor air. In those conditions, the old systems could struggle, whereas a DOAS system can be designed specifically to handle those kind of requirements. Okay, and there are some other systems like VRF. We are all familiar with VRF, chilled beams. Those cannot handle any fresh outdoor air requirement. So in those cases, a DOAS system is absolutely important, so that fresh ventilation air can be supplied to the occupied spaces.
Yeah, I think that these systems are going to be increasingly important. I think you could see not just in new buildings, but I think you could see, these systems being retrofitted in existing buildings because they're so vital now for getting people back into the office. we mentioned previously, prior to the pandemic, a lot of the focus for building owners and on HVAC was efficiency, saving money, saving energy. Now, as we shift to focusing on bringing outdoor air in to the indoors and keeping workers safe, how do these two focuses what is the balance here between outdoor air and energy efficiency? Can they coexist? Where is this trending?
Yeah, that's a great question, John. I mean, yeah, we all know how important energy efficiency is, right? And then, of course, can we increase the indoor air quality by increasing the efficiency also? That's a question that we need to ask every day. And with climate change and sustainability in the backdrop, that those two are very important questions. So bringing outdoor air by itself, okay, depending on the building load and ambient conditions, it could be an energy saving affair or an energy intensive affair. Okay, it depends on what the conditions are. But if you always want to supply fresh outdoor air, I would say you need to spend energy because there are conditions where you need to remove a lot of humidity. You need to cool down the outdoor air. So these are all energy intensive process. So if you don't want to bring fresh outdoor air, that's the most attractive option from an energy efficiency perspective. But we all know that's not a solution that we want to go with in the future. We need to bring fresh outdoor air. So it could be at the end, it could be an energy intensive affair. But fortunately, we have technologies that can help us improve the process, making it energy efficient than just bringing and dumping fresh outdoor air. We have technology solutions that we have focused on energy efficiency while increasing the indoor air quality.
These technologies are going to be critical, because if you give a property owner the choice between saving money with nobody in the building or spending money on energy and having people in the building, they're going to choose the latter. I mean, that's obvious, and we're already seeing that. So tell us a bit about these technologies that can help mitigate the energy impact of bringing in a lot of fresh outdoor air.
Yeah. So as I said, fortunately, while it can be energy intensive, we can make it efficient. So one of the technologies that I want to highlight is the variable speed technology. Okay, this could be both for a compression and the air movement in the building. So as the name suggests, it's variable speed. So you are changing the speed of these systems as the load changes. Okay, so from a compression standpoint, when the building has less load, then you reduce the speed of the compressor. Okay, and when you need more capacity, you increase the speed of the compressor. So this really helps you match your capacity of the unit to the load that building puts in. And what that effectively means is that you're not wasting energy when it is absolutely not needed. Okay, the same way, you could have variable frequency drives on the fans and blowers, because sometimes you don't need to bring in as much fresh outdoor air, or then you could really reduce the speed of the fan. And reducing the speed of the fan by half actually reduces your power consumption by an eighth. So that's a significant energy savings when you use variable frequency drives on the fan systems. So that is the first technology I would like to highlight when it comes to how can we improve the indoor air quality on the same hand, increasing the efficiency.
And yeah, we've talked about variable speed technology. In fact, we did another podcast on indoor air quality with Francis Dietz of HRI, and we talked about variable speed technology and how it can increase the airflow. Usually, especially in a traditional rooftop unit, when the compressor is on, it is, there's no outdoor air coming in. When it's off, it's in ventilation mode. Yes. And the fan's running at 100% the whole time. So having a variable speed option where you can slow the compressor down, slow the fan down, but still bring in outdoor air the whole time, I think not only saves energy, but will increase that airflow and make the building safer.
Yeah, absolutely, John. That's very critical going forward. Is okay, you have to match your load to the capacity to the load. So unless you match that, you are just wasting energy. That's absolutely correct.
I think variable speed is going to become even more important as we go into the future. Right. Tell us about one more technology that can help save energy in this new environment.
Okay. Yeah. So as I said, bringing in a fresh outdoor air is energy intensive, right? So for example, if you have a decently good but humid spring or fall day, okay, you don't want to change the temperature of the air. You want to bring more outdoor air because the temperature is very good. But then it could be very humid. So you are actually removing a lot of humidity from the air. And taking humidity of the air is a very, very energy intensive process. You remove the moisture, it takes a lot of energy. But then the side effect is that you're cooling the air significantly lower temperatures. And you don't want to supply that cold air on a very good spring day, right? So what you do is you cool down, but you again bring it back to a temperature that can be supplied to the zones so that it's comfortable. In order to do that, we use what is called a reheat coil. And the best way to do that is to use a compressor discharge heat that otherwise is just wasted. Now you use that compressor heat to actually reheat the air instead of spending electricity or gas. So this is a very sustainable and energy efficient process. It's basically heat recovery. But
we've talked about heat recovery in other applications and chiller applications, but this is another example where heat recovery, in a package system can really help save a lot of money and mitigate the effects of bringing all this outdoor air. So I think heat recovery, again, just like variable speed, as we kind of go into the next few years, is going to be an increasingly big part of what we're doing in HVAC.
Right. I mean, there are many avenues for heat recovery, and this is just one example of it. And we need to. There is a technology called microchannel heat exchangers, which makes this reheat applications even more efficient, because these are very small coils, and for a given phase area, these coils can perform extremely well compared to the old fin and tube technology. Okay, another aspect here, just in addition to being efficient, is that these are really, really small coils, so the refrigerant charge in them is very small. Okay, so that's a good step towards sustainability, where we are all talking about how can we reduce the charge, use less refrigerant. So that's a good way to be more efficient and also be more sustainable from a refrigerant standpoint.
Yeah, I mean, we can talk about not too many good things came out of the pandemic, but I think as we kind of look for solutions to the problems that the pandemic's presenting, there is going to be opportunity for redesign. There's going to be opportunity for innovation, and that's exactly what you're talking about. Because a lot of these rooftop units, are fairly stagnant technology, but when we start talking about adding the features that you're talking about, it's going to be a pretty sophisticated machine.
Yeah, it's a good time to talk about all these new technologies that can be implemented to increase the indoor air quality and also the efficiency of the units.
Yeah, well, Sankar, I think that's a great place to wrap it up. Thank you so much for joining us. Again, this is a really important topic and something that's not well understood as we kind of move into the next few years in HVAC technology. Thanks so much for joining us. Any final thoughts?
Well, thank you, John, and thank you for this wonderful opportunity. And I'm excited about the future for rooftop and package systems. There's a lot of options, and this is a good place to explore all of those. Yeah.
Well, great. That's it for this episode of the EnVisioneering Exchange. Again, I'd like to thank my guest, Sankar, our global application expert for package systems and data centers. And don't forget to subscribe to the EnVisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever it is you listen to your podcast. Lastly, if you enjoyed this episode, don't forget to rate, review, and share it with your network. My name is John Sheff, Danfoss's Director of Public Industry Affairs. Thanks for listening. We'll talk to you next time.